It's just kind of a way for you to kind of go back after a core class and take an extra look. One warning, it takes time. So what I do today might not be up before Wednesday. It may or may not. It takes me a little time to get it all posted. But I try to do what I can. But the other thing is that I've taught this course enough times that there's other things we can look at. So if you didn't understand section 2.2 today, you can kind of look at what's been done in the past. And that's not a bad thing. All right, so let's write down our function. F of x equals 0.01x squared minus 0.71x plus 16.8. That's a function. All right? And again, my variables are x and I guess f of x, which variable do you usually use? You use y for the output, right? But we write f of x because we want to emphasize that x is my input here. Whatever's in the parentheses is my input. And so they're talking about the input here. And actually, you know what this is giving me? There's a name for this little guy here. Almost. That's the other one. The domain. That's the domain. I'm glad you said the word range. The range is the set of all possible outputs. And the domain would be the set of all possible inputs, right? And so these are ideas you learned in an algebra class at some point that I think are worth mentioning. The other thing that you want to talk about, again, this is an applied class. Anytime that I write down a function, I want to say what x represents, where x, and I might say, represents, you know, and then I might say what f of x represents also. Does it tell me there? It says per capita consumption, right? So f of x is per capita consumption. What does that mean? That's something that you and the group might talk about in a minute. Oh, it's off the screen. Per capita consumption. So what does x represent? That's on the next page. It says number of years since 1980. X represents the number of years since 1980. Okay? So now it says, does the graph of f open up or down, part A? And how can I tell this by inspecting the function? By the way, there's more to this that I should probably give you. I mean, what are we studying here? This is a function. Let me go ahead and move this for a second and maybe just give you a little bit of notes here. Okay? So section 1.3 is the one section that I plan on covering in class from chapter 1. Okay? And it's entitled, well, quadratic functions and secant line slope. And already it's starting to sound like, hey, we're in a pretty technical course here. That's a lot of mathy words there. Okay? But you've heard these before, or some of them you have. The word quadratic, usually what's followed by the word quadratic? Quadratic what? All right. We're going to pause for a minute and let you and your group see if you can recite the quadratic formula to each other. Let's see. My algebra teacher, I remember 9th grade, negative b plus or minus the square root of b squared minus 4ac all over 2a. How many people have that? You remember that somewhere in the recesses, right? This is called the quadratic what? Formula. And what was it for? Well, it It was used to solve an equation. Can anyone give me the equation that can help me solve? Then why did we memorize this? Go ahead. That's right. It has to have x squareds in it. That's what makes it quadratic, by the way. So the reason that this function is in this section is that it is something x squared. And see, the a, b, and c, that's what the coefficients are. They're called, remember the word coefficient? The number in front of a variable? Ax squared plus bx plus c equals, say, 0. If you want to figure out the solution to this equation, there was a nice formula, which is a real nice way to solve that problem. Okay, that's called the quadratic formula. Well, this is called a quadratic function. Does anyone remember if you graph a quadratic function, what shape it is? Yeah, it's a parabola. It looks like a U. It's not a line, right? A linear function, how could you tell it would be a linear function? Well, it wouldn't have this, right? It would just be degree 1 instead of degree 2. Degree 2 is quadratic. So I actually know that the shape is going to be a parabola. And so now maybe we can understand what part A is really asking. It says, does the graph of f open up or open down? How can you tell this by inspecting the function? I'll tell you what I'm going to do. I'm going to go ahead and put the function into my graphing calculator because I'm going to want that later. Okay? And so let me go ahead and pull out a graphing calculator here. Okay. So let me press y equals. Let me clear out the last thing I had in there. And I'm going to type in 0.01 x squared and then minus 0.71 x plus 16.8. And so I put that in my y equals and I have it, right? And now if I press graph, nothing happens. Why is that? That's right, okay? When you say outside the spectrum, the button on the calculator that kind of tells you what it is you're actually looking at is this window button, okay? And so it's going to give me x min and x max and y min and y max. And see, right now, everything about that graph was outside of the window from -10 to 10, -10 to 10. Okay? By the way, if you ever want this window back, you can press Zoom Standard, and that's the window that'll come up. It's choice 6 under the Zoom menu. So what happens is I've graphed the function, but it's kind of off the screen. So I want to change the window. And by the way, I kind of know what I want for x min and x max. That was given to me, right? Because that's the domain. What should I put in for the domain? 0, 31. Okay. And so that's going to take me, since x is the number of years since 1980, year 0 is 1980. What's year 31 then? 2011? All right, so this is going to talk about milk per capita consumption. Still haven't mentioned that yet. From 1980 to 2011. What's been happening to whole milk? I'm going to press graph again. Well, now I can actually see some of it. You see that? Is that a parabola? Well, we know it is from our algebra class. I can't see the whole parabola, but I can see the part that I'm interested in. You know, so I guess my answer to part A, okay, so part A, I'm going to tell you that this parabola opens upward. Do you understand what I mean by opens upward? Yeah, it'd be U, right? Whereas sometimes a parabola opens downward, right? So it opens upward. It's shaped like this. Even though on the screen I can't see the whole parabola, I can see a piece of it, right? I can see maybe this much of it. You guys with me? Matter of fact, I can't even tell you what the per capita consumption was of whole milk in 1980 from my graph. But I guess I could tell you now. Well, by the way, there is something I can do. I can hit the trace button. Let me hit the trace button. Okay, what's that say? X equals 15.5. Y equals 8.19. So what's that mean? Go ahead. Okay. Yeah, what's that mean? 8.19. Did they give me the units? It says in gallons. 8.19 gallons of milk per person? How could that be? I'm not talking about just drinking milk, right? We're talking about they put it on the shelves for you everywhere, right? This is how much milk the United States consumed per person, right, annually. Hey, what if I want to know in 1980? Then I have to plug in x equals what? 0. By the way, you could do that. If you plugged in x equals 0, what would you get? 16.8 gallons. So from 1980 to the middle of 1995, what would you say has happened to the consumption of whole milk in the United States? Well, it's decreased, right? And it's even decreased since then. Okay, and the graph shows us this. And the numbers tell you what's going on. By the way, if you want to evaluate a particular year, I want to show you how to do that, because this can come in handy. All right, so let's take, what year do you guys want? Thanks for participating. That's really nice of you guys. Anyways, what I'm going to do is I'm going to hit the second button and hit trace. That's the calculate menu. And if I choose choice number 1 here, I can get a certain value. Okay? So I'm going to plug in x equals 10. Okay? And what x equals 10 gives me then, it says y is 10.7. All right? So how would you interpret that answer? Talk to each other in your group about what that means. Okay? What is it? Yep. So yeah, it tells you about the per capita consumption of whole milk in 1990. That's what it tells you. So part B is what I want to talk about next. It says, compute the slope of the secant line of f from 1980 to 1990, and then interpret the answer. And you'll notice I wrote the letter M, which stands for what? M? Not milk. Good guess, though. Slope. So I'm trying to tap into your algebra. And then I put a little SEC. I'm saying slope of what's called a secant line. Now there's a word that I don't expect you necessarily remember, although you may have heard it. So I want to draw the picture a little better and kind of show you what's going on. You know, I guess I need a different graph here, because remember that x equals 0 corresponds to 1980, right? So what they asked me to do is find the slope of the secant line of f from 1980 to 1990. Now we computed that in 1980, which is again represented by 0, that the per capita consumption was 16.8 gallons of milk. And then we just computed when x equals 10, so I'll put a little 10 here, that the per capita consumption has dropped to 10.7 gallons of milk. So not quite in half, but it's dropped. And I guess at that point, then it's almost on the picture, right? Because we know that the top of this picture is at 10. So what we're able to see of the graph, okay, is a parabola that looks something like that, right? Does that make sense to you guys? Okay. So what I'm about to do is I'm going to compute the slope of what's called a secant line. And I guess I should really put that in my notes. Matter of fact, look, that's the other thing that we're supposed to talk about in section 1.3. Secant line slope. Okay? So a secant line, and this is a definition. So a secant line is a line that intersects a curve in 2 points. Whoa. Well, I just did. Secant line is a line that intersects a curve in 2 points. So when they say draw the secant line and find its slope, let me draw the line for you. The line is this. Okay? That red line. And what I want to do is I want to find its slope. Actually, you may remember some things about slope. Why don't I pause and let you talk to your group about how you might find the slope of that line. That'd be worth talking about. I'm going to write down a few things that I heard as people were talking about this. One of the things I heard about slope is that slope is rise over run. And I heard some other things too. You know, when we talk about slope, that's an okay definition, but then how do you use it? I mean, are we really rising here? Well, maybe. I mean, if you think of it as negative rise, it works that way, actually. You can get away with that. Another definition that I heard someone talking about y2 minus y1 over x2 minus x1. How many are familiar with that definition? Okay. These are how you find the slope of a line. I guess if we were going to use that particular form of the definition in our situation, we'd have to call one of the points point number 1 and one of the points point number 2. So why don't I call this number 1 and this number 2? And I'll go ahead and try and use the definition where it says y2 minus y1. I guess what I really want, you could say, is I'm going to take f of 10, right? And I'm going to subtract f of what? F of 0, because those correspond to 1990 and 1980. And then I'm going to subtract the run, I guess, I'll get by subtracting the x's. 10 minus 0. You guys with me right now? Okay. So I need to take, for example, well, 10.7 minus 16.8 all over what? 10. And of course, when I do 10.7 minus 16.8, I'm going to get a negative number, aren't I? I get negative 6.1 over 10. And so the answer I get is negative 0.61. And you could have done that in an algebra class. So now I'm in an applied calculus class. And what's the difference? The difference is the book says I need to interpret the answer. And I wish that they would do this more in the algebra class, actually. Can we interpret the answer? because that negative 0.61 has a real meaning for us. Okay? In order to understand the meaning, you need to look at how you got it. Up here, the line above it is good enough. When I look right above it, I see a fraction. And I want to think about what are the units for the numerator of the fraction, and what are the units of the denominator of the fraction, and therefore what does this tell you? Maybe talk to your group about that for a minute. What are the units? I just heard some really good things. Really good things. So the units for the numerator, I'll write this in red. This is good stuff. We know that this is gallons per capita, right? Per person. And then the denominator is, what's the units? Years. And the fraction bar really means per, right? So gallons per capita per year. Okay? So my interpretation would be the following. From 1980 to 1990, okay, consumption of whole milk, what do you think the next word I'm going to write is? Decreased. How do I know that? Well, one way I know it, even without the graph, is I see a negative slope. Decreased. I'm going to write more. Decreased. What we're saying here is how quickly it decreased. A rate. That's right. And guys, this is not by accident. The title of this worksheet is Average Rate of Change. And that's really what I'm trying to get across to you today. When we say secant line slope, we're finding the slope of a secant line. What that means is, I call it AROC for short, average rate of change. It's the average rate of change. I want you to understand something. Look at the graph. We're talking about the years going from 1980 to 1990. Was it constantly decreasing at the same rate? No. Actually, in 1980, it looks like it was decreasing more quickly than it was, say, in 1990. And now it's not decreasing as much as it was before. But this is negative 0.61 gallons per capita per year. That's the average rate of change. So consumption of whole milk decreased by 0.61 gallons per person per year. But there's a very important word that I screwed up, guys. You want to put a little caret right here. By an average of 0.61 gallons per person per year. I think that's important to understand. Let me show you something. We're going to go back to our calculator. We're going to do this. We're going to type in second calculate of value, x equals 0. Guys, what's it going to give me when I press enter? Thank you, 16.8. I want to do the same thing. I'm going to press second calculate of value. I'm going to type in x equals 1. It's going to be more or less than 16.8. It's going to be, thank you. Okay, we learned something today. 16.1. How much did it go down? 0.7. Is that 0.61? No, it went down more. But on the average over those 10 years, it went down 0.61 gallons. Does that make sense to people? computing an average rate of change. Okay. I think you're at the point, honestly, where you've learned enough that you could probably complete the rest of the exercise, which is great. Lets me turn this off for a little bit. And I'm going to go ahead and circulate the room and say some hellos, try to get to know some names. And anyways, we'll do this for a little bit. Once you're through with the entire worksheet, we're going to bring it back up front here, okay? Is talk about question F here, graphing the functions. We already have a viewing window of 0 to 31. It says, just so you understand what the book means, 031 by 020. What they're giving you, in a sense, is the domain and the range that they want to see. So when I go to my graphing calculator and I want to graph these functions, they're telling me, click the window button. X-min and X-max go from 0 to 31. Y-min and Y-max are 0 and 20. That's what they're telling you. Okay? Now, if you don't have the window, you can still make use of the calculator, right? As long as I know the x's, you can find values that are not on the screen, all right? So, but this is a particularly nice problem because they tell me, hey, this is the window. A lot of times the hard thing to do is to find the function, okay? So now I'm going to go ahead and press graph. Okay? And there it is. So that's f of x. Oh, we didn't graph g of x yet. I should do that, right? So let me go ahead and plug in g of x. So what the heck was g of x? Oh, there it is. So I'll hit the y equals button. And I'll go down to function number 2 and type in negative 0.01 x squared plus 0.48 x plus 10.83. Okay, let me graph those. All right, and now it says, use the intersection command to determine the point of intersection of the functions. I could see the point of intersection of the functions. By the way, then it says, round to the nearest whole number the x value of the point of intersection of these functions. What is the meaning of this value? All right, so let me just show you how to do that. I'm going to hit second, calculate. And if you notice, choice 5 is what I want. Intersect. And now it asks you, what's your first curve that you... And the reason they're asking you this, sometimes you may have 3 or 4 different curves on the screen. And you say, hey, find the intersection. There could be lots of intersections. So it says, all right, what's your first curve? I picked that one. That was F, Y1. And now it says, what's the second curve? And I'll pick that one. And now it's going to ask one more thing. Do you have a guess of what the answer is? You don't have to say anything. You just press enter and go with it. One of the reasons they ask is because let's suppose these two curves intersect in more than one place, which they do, by the way, if I drew the entire parabola. Well, depending where your initial guess is, you may end up at one intersection or the other. I'm going to press enter and see what happens. Well, there it is. Intersection 5.5, 13.17. So I guess if I'm doing this part F, okay, I would, maybe I'll just go to my notes here and write some of this down. So let's see. This is page 48, part F, okay? The graphs of f of x and g of x intersect where? Well, it says when x is approximately equal to 5.5. Okay? And now they want me to interpret that answer. Okay? And so what I'll say is my interpretation is this. After, well, what would that correspond to? The year 1985, right? Or 1985 and a half. So after 1985, the per capita consumption of whole milk was less than the consumption of other milk. Of reduced fat or skim. It's kind of funny. I mean, I don't know if you guys go over who drinks what kind of milk in your group. Well, I would have. When I look at how the book says to do the type of problem that we just demonstrated, find the average rate of change of this function on this interval, right? Here's a generic example. They didn't tell me what the function represents. Probably doesn't represent anything. But it's a parabola, right? And you'll notice that they write down m secant, slope of secant. And then they write this down. And that may confuse you. So I want to write it down to confuse you. No, I want to write it down and demonstrate what it actually means. Okay? What's that? The delta, yeah. So they wrote down this. M secant equals. And the denominator was delta x. How many people are familiar with that notation? The Greek letter, what does that mean? Okay, so we know that. Change in x. As a matter of fact, I mean, just going back to slope, when you guys told me it was rise over run, I did hear someone say this. I don't know who it was. I wasn't listening that carefully. Delta y over delta x. Change in y over change in x. Well, that's really what's going on in the book here when they write this formula. They wrote f of x plus delta x minus f of x. Okay? So let me go ahead and show you exactly what's happening here. Delta x, that means how much are the x values changing? Well, we're going from 1980 to 1985, so we're going from 0 to 5. So how much, what's my delta x in this problem? 5. So the denominator there is 5. Okay? Now the numerator, well, I guess you need to understand what we mean by f of x and f of x plus delta x. Because you know what to do. What you're doing is you're going to do f of 5 minus f of what? 0, right? But I guess in the formula, that's where this is a little confusing. If it were me, I probably would have written f of like c plus delta x minus f of c or something like that. So that you don't think f of x, you're thinking of a number. What we're really doing is f of 0 plus 5 minus f of 0, because delta x is 5 here, and the x value or the c value is 0, because that's kind of where I'm starting. I'm starting at 1980. I'm going to 1985. Does that make sense to people? But, you know, once you get this far, I'm sure you guys, what'd you get for an answer for this one? What'd you get? 0.43? Okay. Oh, wait, I said don't do f. I said do G. Did you guys do G? Okay, good. Change those all to G's. And then we get 0.43, we said? Interpret the answer. Well, again, the units are what's most important. Gallons per capita per year. And I guess one more word that would help me here is if I say we are increasing that amount. Right? What'd you get for an answer for part H? You could do the same thing. You would just do g of 8 minus g of 5 over 8 minus 5. That's the slope of the secant line. And what'd you guys get? 0.35? So we are increasing 0.35 gallons per year, let's say. All right? And again, I want to see that. How the heck do I get that? Well, so I guess I really don't need F anymore. I need G. Bless you. So I'm going to go back to the y equals screen, and this is a nice trick to know about. If I go on top of this equal sign, I can select it, and now it's not highlighted. With some of the newer calculators, you can also do this in a slightly different fashion. So now I'm just going to graph one of them, but I still have the other one if I need it later. And so, for example, second calculate a value. Well, let's try 8. So you say it's 14.03. Minus, I need g of 5, so I'll calculate a value. And what am I really doing here? When I say plug in x equals 5, I want you to understand, I'm sure you did this in your algebra class. How do you get g of 5? Well, what you do is this. If g of x is negative 0.01x squared plus 0.48x plus 10.83. You understand what I'm doing when I say g of 5 is everywhere there's an x, I'm putting what? 5 squared plus 0.48 times 5 plus 10.83. And I work it all out, and I get 12.98. Right? I just want to be very clear about what we're doing. And so I get, now at this point I'm going to use a calculator. I'll hit second quit, go straight to the regular calculator screen. 14.03 minus 12.98. I get 1.05, and then I take that and divide by 3. And I agree. 0.35 gallons per year we're increasing on the average from 1985 to 1988. All right? So let's look at the picture. Where is 1985? Let's look at that again. There. In 1985, skim milk, would you say that the consumption was increasing or decreasing? In 1985, you're saying that it was increasing. I would say that too. Now, what did we compute? We computed from 1980 to 1985 what's called the average rate of change. It was increasing a lot then. From 1985 to 1988, was it increasing? Yes, but not as much. Do you see that? So what I might want to know is, how fast is it increasing in 1985? Is it 0.43? Is it 0.35? Is it something between those? This is where you need calculus. Everything I've done today is algebra. That's why it's chapter 1. A lot of it's just learning terminology. But once you learn the terminology, it's nothing complicated. Okay? But where we're going to need the calculus is, we may want to figure out, yes, we want to say it's increasing in 1985, and we want to say how fast it's increasing. You notice when I pick 1980 or 1988, I get different answers. But I'd like to say something about the rate of change now. Not an average rate of change, but an instantaneous rate of change. That's Wednesday's class. On Wednesday, I'll show you how to answer that question. I can't quite do it today, even though we're going 3 times as fast. I can't do it. What it's going to involve is an idea that we start in chapter 2, and I'd like to start that with you now. It's an idea called limits. Limits. So, let me do that. Let me get you some notes from chapter 2.